Good morning, students. Welcome back to your mathematics class. Today, I'm going to continue the same topic we dropped last day, that is transformation formulas. I have provided you an introductory class to the transformation formulas, and we have derived it from which formulas? Yes, that is compound angle formulas. I hope all of you have went through all the sessions, and definitely all the formulas are learned by you. Okay, please do make a chart of it or write down all the formulas in your copy and try learning every day. So today, continuing with the same, I will be solving certain problems based on transformation formulas. So let's begin the class. Okay, so here are the very famous, very common problem of your textbook, that is, show sine 20, sine 40, sine 60, this is the known one, okay, sine 80 as 3 by 16. So many unknown angles, I would say, except one. But I have to prove this product as 3 by 16. So, the transformation formulas we have learned last day will be helping me to solve this particular product or to reduce this particular product to just a real number, that is 3 by 16. And let us see how it is possible. But before that, I want you to recall by writing the formula of 2 sine A sine B. Now, 2 sine A sine B can be written as cos of A minus B minus cos of A plus B. You can even write down this first and this later on, but remember in that case to put a minus sign here. Now, I would advise you all that whenever you are applying some formula, you must write down in the side and you must show to the teacher that you have applied this particular formula in this particular problem. Okay, students? So, remember this one very nicely. Now, here we are going to apply the one. So, we are going to take this 2 altogether. And this particular is root 3 by 2. So let us write down that. So here I am writing root 3 by 2. And a 2 is multiplied. So this becomes 2 sine 20 into sine 40. I hope it is understood. It is multiplied with a sine 80. Now, this is the LHS part I am starting with. Okay, this is the LHS part I am starting with. Now, this is root 3 by 4. And this 2 sine 20 into sine 40 is carrying on the formula of cos. See, cos A minus B. So, see, I am writing here 20 minus 40. So, 20 minus 40 is minus 20 degree. Minus 20 plus 40 is 60 degree. Okay, now this is multiplied as a whole with sine 80 degree. So, what is cos of minus theta? Cos of minus 20 degree is going to provide me cos of 20 degree. Why? Because in the 4th quadrant, cos is what? Positive. Okay. So, cos of minus theta is cos theta. Okay. So, I am going to remove this minus sign, and here in front of you, one is known, another is unknown. So, the known angle is 1 by 2. So, let us substitute here 1 by 2 for cos 60. Fine. Now, this is all alone. Let us bring it inside. But I would first take out this half in the form of LCM and see if this step is clear to you or not. A very simple multiplication of sine 80 inside. So this is 2 cos 20 minus 1. This 2 comes out as, okay, 4 into 2 as 8. Now this sine 80 multiplied 2 cos 20 into sine 80 minus sine 80 into 1. Okay. Now again I hope you can understand. It's time to apply the formula of 2 sin A cos B or 2 cos A sin B, anything you wish. Yes, anything you wish, because we are going to get at the last the same result if we are going to apply the correct formula here. Okay, so from here I'm rubbing this, erasing this part. Now this one, see this one, 2 cos 20 into sine 80. 2 cos A sine B can be written as sine of A plus B minus sine of A minus B. And I hope all of you can recall well, because we have already discussed these formulas in the previous classes. Okay, so here it is A and here it is B. So what it is, after this step, look very carefully here. So sine of A plus B 100 degree minus sine of A minus B, that is 20 minus 80. What it is? Minus 60. But sine of minus 60 is how much? Yes, that is minus sine 60. Because in the fourth quadrant, cos is positive, but sine is not. So I will jump a step here and see, I have put a minus sign, but again a minus comes from the formula. So minus minus become plus with a sine 60 degree. Now already a minus sine 80 was there, not to forget. So here it is. Now tell me, this sine 60 is root 3 by 2. It is clear to everybody, and you are also like in a hurry to substitute the value. But don't forget that we have two more things here. That is sine 100 degree and sine 80 degree. Now, how to convert it? Look, sine 180 minus theta is how much? Yes, the answer is sine theta, because in the second quadrant, sine is positive and sine remains sine only. Don't you think so? I can substitute here sine 180 minus 100. See what I have written. If theta here is 100, is sine of 100 degree. Look, sine 180 minus 100 is again sine of 100. But what is 180 minus 100? Yes, this is 80. Is it okay that sine 80 is sine 100? Sine 80 is sine 100. So a minus sign is there in between, which is cancelling down, and we are getting what? We are getting only a leftover, that is sine 60 degree. So which is root 3 by 2, and that root 3 by 2 multiplies with this root 3 by 8, and we are getting the ultimate answer of 3 by 16. So what I am telling you, that the answer is now going to become 3 by 16, and that is matching with the RHS, the one we require. Now children, you will be writing all these proofs, not proofs, the formulas. The formulas and the theory you're applying here to cancel down this 100-degree and 80-degree. Fine. So this is the first problem. This is the first proof we have already completed, and two transformation formulas were applied here. Isn't it? So let us move to the next problem. Here, similar to this type, I would like to tell you that what happens if you are going to get tan 20, tan 40. So proof tan 20, tan 40, tan 60, tan 80 as 3, or it may be even asked as evaluate or reduce it to a real number. Whatever be the problem, here we have to again use the transformation formula, and one known angle here is tan 60. As tan 60 is root 3, we are moving it out from the product and we are left out with tan 20, tan 40 and tan 80. Now, I need to tell you one thing here. This particular problem, listen very carefully. This particular problem can be done by converting the tan into sine by cos. That is absolutely correct. But I will be trying out this problem in front of you with some different techniques. And I hope you will understand that better, and that is quite easier than converting it to sine and cos. So let's continue with the process I was talking about. Here, this is tan 20. Keep it as it is. Can you reduce this 40 and 60 in terms of tan 20 and take the help of a known angle, that is say 60. See what I am doing. Try to understand. Tan 20. Tan 60 minus 40. Can we write that? Yes, it is 40. Can I write 80 as 60 plus 20? Yes. No? So, in this problem, you can move on with transformation formula. But I am today moving this problem with compound angle formula. Compound angle formula of tan. That is tan of A plus B. What is that? Tan A plus tan B? Yes, 1 minus tan A tan B, isn't it? And tan of A minus B here, tan A minus tan B by 1 plus tan A tan B. All the formulas must be written to the side whenever you're going to apply, whenever you're going to use it. Okay, so I'm going to substitute the one I said now. Let it be tan 20. Now, here it is. Tan A minus tan B. That means tan A is what? Tan 60. Tan 60 is root 3. So, root 3 minus tan 20 by 1 plus root 3 into tan 20. Okay. Now, this is root 3 plus tan 20 by 1 minus. See children, this is a mere application of the compound angle formula of tan of A minus B into tan of A plus B. Now, what is the resultant of the product? In the denominator, don't you think so we are getting A plus B into A minus B? Same is the case in the numerator of A plus B into A minus B. So, here it goes. That is 3 minus tan square 20 by 1 minus 3 tan square 20 degree. I hope it is clear. Just a multiplication and just application of the a plus b into a minus b formula, that is a square minus b square. See, this 2 and this 2 in the denominator are multiplied here. Correct. And I am putting some brackets here. Okay. Now, after this, listen very carefully. This tan 20, I am going to multiply this tan 20 here inside. Okay. So, after multiplying, see, I am erasing it and I am going to rewrite this here. See here after this line. That is 3 tan 20 minus tan cube 20 degree multiplied with, and it is the denominator. Here it goes. Tan 20 gets inside and here it goes. Now, I want to tell you something. We have not yet reached the multiple and submultiple formulas, but I would like to tell you this is giving me a multiple angle formula of tan 3 theta. Okay. So we will later on discuss in the next classes, but not a problem. We can recall, we can learn from now only, because when the method is easy, when the method is comparatively easy, becomes easy with the application of a formula, we must accept it and we are happy to solve it in few lesser lines. Okay. And the time is required very much so for completing so many problems in the marking scheme, as I hope you have already remember, all of you remember the marking scheme, the number of problems which we are going to get in the examination. So time is a very important factor, you know. So try to manage the time. Sit with your stopcock, with your watch and complete your problems. That will help you out. Okay. It's not about only solving the problems. It's about solving the problems, completing the problems in time. Okay. So let's see. We are already on the step of the answer. So it is already finished. I'm going to apply here the formula of tan 3 theta. So what is theta here, by the way? The theta here is, that is 20 degree. Isn't it? So this is root 3 into tan of 3 theta. Theta is 20. So 3 into 20 is how much? Yes, that is 60 degree. So can I write it directly? I hope you won't mind writing with a direct, because we all know the formula of tan 60 degree. So root 3 multiplied to 3, we all know what we have to prove. This is the RHS we need. And when you will collectively write down in your copy, put down in your copy, you will see only hardly 3 to 4 lines are actually required. I have explained you, so it might look bigger. Okay, but these are only few lines and my problem is done. And if you move on with sin cos, it might take few more lines. So this is the process. I hope you like it and try out these problems. Okay, so now moving on with this, there is one more problem I would like to discuss with you in this particular class. So here is the third problem. Sin alpha plus sin beta plus sin gamma minus sin of alpha plus beta plus gamma. We need to prove it for sin, see this one, alpha plus beta by 2 sin beta plus gamma by 2 sin gamma plus alpha by 2. Okay, so this is what we have to prove. So I will continue obviously from the RHS part, and not RHS part, sorry, it is LHS part, and the formulas to be used are, I hope, very clear to everybody. So what is the formula of sin C plus sin D? Always recall, always write down, as I said in the last two problems, 2 sin C plus D by 2 into cos C minus D by 2. Okay. So you must write down the formulas always. So I am here writing the formula, that is 2 sine alpha plus beta by 2. See this? Cos of alpha minus beta by 2. Okay. Now, in the next two halves, this and this, again apply the same formula, that is sin C minus sin D, 2 sin C minus D by 2, but cosine C plus D, so can I write directly, that is gamma plus gamma, twice of gamma, plus alpha plus beta by 2. Now students, here we are getting some cancellation parts, that is gamma gamma cancels here, and we are having minus alpha minus beta. That minus part is coming out, and here it will be a minus sign, and something which is common that should be taken out in the next line, that is alpha plus beta by 2. 2 alpha plus beta by 2 in the bracket, cos alpha minus beta by 2 minus, why minus? Because already a minus sign is taken common, so minus cos this part, that is alpha plus beta plus 2 gamma by 2. So here you see what it is, a common part, and the next two parts are here in the product form. So cos C minus cos D coming here. See, cos C minus cos D, let us apply there. So what is cos C minus cos D? I wish I could have asked you in front of me, and many of you will be shouting and telling me the answers quickly. Obviously, that would have been another good interaction with you students, but here I am only asking the questions and I am only going to tell you the answers. This is what. So when a minus is there, so I will write the answer in what terms? Yes, sine terms. So it is 2 into sine C plus D by 2, and definitely C minus D by 2, but a minus sign comes out. So let's see what happens. So this plus this by 2, this is going to become a bigger one. See, alpha minus beta plus alpha plus beta plus 2 gamma by 2 by 2 and the bracket closed. Okay, multiply 2 cos D minus C by 2. So let's do it orally. This is D, this is C, as I told you. So D minus C, fine. So I'm going to write down here. So when it is D minus C, this is minus to this is. Okay. So in that case, alpha plus beta plus 2 gamma minus alpha plus beta by 2, again the same thing. Now see which are the things which is cancelling in the first part, that is beta cancelling. In the second part, this alpha cancelling. Now what you are getting, students, that is alpha plus alpha 2 gamma by 4. Okay, and here it is beta plus beta 2 beta plus 2 gamma by 4. Fine. So this is 2, this is 2, 2 2s are 4. This part is very important. Please see here. 2 2 4. The same thing alpha plus beta by 2 is written. This is same, no changes here. But this let's do orally. So 2 alpha plus 2 gamma by 4. So that 2 cancels. I am getting here sine alpha plus gamma by 2. Because that's 2 by 4, it is cancelling down. Okay, now in the second part, the last but not the least part, here we are near to the answer now. This beta plus beta is twice of beta as said. So this is again giving me beta plus gamma by 2. This is what we actually required to prove. So we started from here and we reached here. Go through the problem once or twice and try out by yourself, because this is not a tough problem. This is only like lengthy, and with full concentration you have to carry on the process. Okay, so like that, so many other problems are there in your textbook, and you may go with a reference book. Now it is advisable to you, all the students, please listen this very carefully. You are required to make a classwork copy for the mathematics. As I always tell you, to put down and to recall and to learn. So you have to make a classwork copy. So from the very beginning of the trigonometry, whatever I have done, whatever problems I am giving you, whatever homework is there, you all practice in the same copy. So collectively, whatever your teachers are doing, it will be there. And definitely the simultaneous chapters, whatever is carrying on in your this session, both should be put. Fine, students. So I would advise that this is how you should carry on with your classes. It will be helping you to keep your notes all together. So this is all for today's class, and go through everything, and we will come back with another set of problems in the same chapter. This is trigonometry. So meanwhile, so you all practice, learn the formulas. That's all for today, students. Have a good day.